give me just a second to get this all put in here properly. Okay, so today we're going to go over 3.4. Now, it's different. The way chapter 3 flows is 3.1 really just introduced how to graph a coordinate, right? How to check to see if a coordinate lies on a line, and then how to graph a line using a table, right? That was section 1. Section 2 introduced slope, right? It was really 2 and 3 really introduced the concept of slope, graphing out of y equals mx plus b, but not really. I mean, other than the formula for slope, it really hasn't been formula driven up until this point. In 3.4, though, we're going to really focus on creating the equation of lines. We did that a little bit in 3.3, where we had the graph of a line and we put it into y equals mx plus b. I think I did that in the lecture. I mean, I think it was in the homework at the very end. But this time, there's a lot less graphing involved. It's not going to be as visual. It's going to be more formulaic. So, and your book titles it, more equations of lines. It starts on page 206 if you want to follow along. I'm going to kind of follow along with the book here to keep it consistent with the verbiage when you're doing your homework and the test, actually. So the first thing your book brings up in 3.4 is a new equation of a line. Now, it's called the point slope form. So the point slope form. So if you hear point slope form, this is what I'm talking about. Now on the test, if I ask you to put something in point slope form, this is what I'm talking about. I want you to put it in y minus y1 equals m times x minus x1. Now look, this equation comes directly from slope, okay? It's the equation for slope. Look, if I divide x minus x1 on both sides, I get the equation for slope over here. So it's just another way to kind of manipulate the slope equation. But now we're not going to use it for slope. We're going to use it to find y equals mx plus b. That's the real reason we utilize this equation. It's to find y equals mx plus b. So first, though, let's just put things in this form. Okay. Let's say we know a line goes through, let's just use some coordinate. Let's say like negative 2, 5, and has a slope of 4. Okay. So look, we know a line goes through negative 2, 5, and it has a slope of 4. Let's put it into this point slope form. Now look, the indicator, we would even do this. Well, if I ask you to do it, of course, that's the first indicator. But the indicator that we're going to use point slope form is we're given a point and a slope, okay? We're given a point, we're given a slope. We're probably going to use point slope form. But at first, though, I'm going to say put in, now I'm going to write this a little shorthanded PS form, okay? So I don't have to write point slope over and over again. Put in point slope form. Well, look, here's our x1 and our y1. They're right there, right? And then here's our slope. We know this is m, right? Because it's the slope. So it looks just like this. Y minus 5. It's always subtraction. Remember that equation for slope was always subtraction. It was the difference of the y's, right? Difference of the x's. So there's always a minus on there. Equals, our slope is 4. And then x minus a negative 2, right? X minus a negative 2. Now we're going to clean this up. We're not going to leave 2 negatives hanging out there. We're going to say this is x plus 2. So this winds up being y minus 5 equals 4 times x plus 2. Boom. And we've put this information, really, just some line in space, really on a two-dimensional plane that goes through this coordinate and has this slope. If I wanted to write it in point slope form, there it is. Okay, there it is. Okay, I'm gonna put my drink over here. So I'm not doing that. Okay, so any questions other than let me just see that a few more times. Okay. Let's see here. Let's do. Let's say I've got. Okay. Let's say instead of 2 point or a point and a slope, let's say I give you 2 points. Given a line goes through, let's say -2, 1 and 4, 3, find point slope form. Okay, find point slope form. Now I'm going to write point slope form over here just so I remember what it is. Remember, it's y minus y1 equals m times x minus x1. Okay, now this one's a little different. The last question, it gave us the slope, right? It gave us the point and it gave us the slope. This one's giving us 2 points and it's not giving us the slope. And for point slope form, you have to find the slope. Well, we know if a line goes through these 2 coordinates, we can find the slope of that line. We learned that equation yesterday, right? So let's do that first. M equals x1, y1, x2, y2. Let's find this slope like we did yesterday, right? And if you did the homework, this is easy stuff. 3 minus 1 over 4 minus a -2, right? 3 minus 1, subtract the y's, and then subtract the x's. So we wind up with 2 on top, 3 minus 1, and then 4 plus 2, so you wind up with 6. So you actually wind up with 1/3, right? We found the slope of the line, and it turns out the slope is 1/3. Okay, now this is when it gets kind of goofy. It's point slope form. We only need 1 point, but we're given 2 points in the kind of the premises here. Okay, so it doesn't matter actually which coordinate you use. There's going to be two right answers for this one. Okay, so you can plug in the first coordinate. If you did that one, it would be y minus 1. Remember, I'm going back to this equation. Y minus 1 equals, our slope we found was 1/3, and then x minus a -2. Now I'm going to be a little lazy here. We call that efficient in mathematics. If I know it's going to be x minus a -2, I'm just going to automatically put x plus 2, okay? Because we know we're just going to be changing the sign. So that's one of our solutions. Now, look, if you chose to use the other coordinate, maybe because it's 2 positive numbers, you don't have to worry about changing signs. You're right as well. There's just 2 right answers for this one. So y minus 3 equals 1/3 times x minus 4. Either one of those are correct for this one because they gave us 2 coordinates for our line, okay? That doesn't always happen, but it might, okay? And it's okay. You'll see even in the book, it'll say this or that, right? This answer or that answer, which is completely okay. Okay. Questions, comments, concerns before we get going here? Hold on. Let me see something. Make sure I'm not doing anything crazy. Yeah. Okay. So now I'll tell you, the goal of point slope form is really to get equations of lines into other forms. It's typically used as a go-between, I guess you can kind of think of it. And there's 2 forms that we're going to talk about. And the first one I'm going to talk a little bit more. I know I didn't do that last time. This standard form of a line. Let me go back and see where your book introduces it. It might introduce it way back in section 1. Hold on. It comes up again here, and I forgot how much Dr. Martingale likes this equation. Yeah, it's if you want to flip back to page 173 in your book if you've got it. If not, it's not a big deal. But remember, there's 2 forms of a line that we've really talked about before already. There's standard form. Run that ink here, which is ax plus by equals C. That was the one on page 173. It was the very first day that we talked about, we lectured actually from 3.1. That's called standard form of a line where A, B, and C are real numbers. A and B are both not, they can't both be 0. Yeah, not a big deal. So that's standard form. The other one is a slope-intercept form, which we talked more about yesterday, which is the y equals mx plus b. And what's nice is if we're given information, it's easier to put information typically about lines in point slope form and then put it into the standard form or the slope intercept form, okay? And that's why we use this point slope form typically. Now on the test, if I say, hey, given this information, put it in point slope form, that's what I want. But if I give you the same information, and let's say I ask you to put it in standard form, and I'm going to steal the example right out of the book, actually. If you're following along, if you've got the book yet, if you're following along, it's on page. Yeah, it's on page 206 at the very bottom. Okay, it's example 2 on page 206. I'm just going to steal it from the book. And I'm going to try to get a new marker that's got some more ink. We'll see if any of these do. So this question says, write the equation of the line, and it goes through (4, 0) and -4, -5. Okay, we've got some line, and it goes, now they use more words than this, but it goes through 4, 0 and -4, -5. But they want us to write the equation in ax plus by equals c form. So remember, this is called standard form. So they want us to write this in standard form. So I want to go through this real fast so you guys can kind of see the step-by-step way of doing this. Let me make sure my phone's on silent here. The first thing we're going to do is exactly what we did in the last example, okay? We are going to get this, and even though it's not asking us to put it in point slope form, if we're given 2 coordinates, we know it goes through these 2 coordinates, and it's asking us to put it in this form, we're going to first put it in point slope form. Okay, so step 1, put in point slope form. Okay, put in point slope form. Now, this is the example we did right before. So remember, if we want to do point slope form, first we need to have the slope. So here's x1, y1, x2, y2. So we get -5 minus 0 over -4 minus 4, right? -5 minus 0 over -4 minus 4. So we wind up with -5 on top and -8 on bottom. Well, 2 negatives, just like when you multiply 2 negatives, when you divide 2 negatives, you wind up with a positive. So you wind up with 5/8. Okay? Okay, so now let's put this in the form. And again, it doesn't matter which one you choose, but I'm going to tell you, if I've got an option with a 0, I'm choosing the 0. 0 makes our life a lot easier, okay? So I'm going to do that. I'm going to choose the coordinate with the 0. Either way, it doesn't matter. We're still going to get to the same form, okay? So we get y minus 0 equals 5/8 times x minus 4, right? This was point slope form. Y minus y1 equals m times x minus x1. Brackets here instead of parentheses. Okay, so first we put it in this form. That is done. Okay, so now step 2, we're going to have to manipulate this into ax plus by equals c. So I'm going to write that down. I'm even going to write it like that. You're going to manipulate it. into standard form. Manipulate this thing into standard form. Okay, so there's a few ways to do this. So I really want you to pay attention because I know all of us love fractions. But what's nice is if you have an equal sign, there's a quick way to get rid of fractions. So first off, y minus 0 is just y, right? Y equals 5 over 8, x minus 4. Okay, so here's what we're going to do. And I'll use another color here just to kind of emphasize how this is kind of neat, okay? So if you've got a fraction, look at the denominator, and we're going to multiply both sides. It's an equal sign. As long as we do it on both sides, we're fine. We're going to multiply both sides by whatever that denominator is. Okay? Multiply both sides. Now notice this is all multiplication here. Okay? So when we do that, it cancels out that denominator. Okay? 8 divided by 8 is just 1, right? It goes away. So we wind up with 8y equals 5 times x minus 4. Yay! No fractions. I know you're going wild behind that screen and thanking me and cheering me. I understand. I'll just take that. The silence is cheers. Okay. So anyway, now we got to get it in this form. Thank you, Avery. We've got to get it in this form. So look, the goal here now is to get the x's and the b's on one side and the constants on the other. Now notice there's no parentheses here, right, in this form. So we've got to get rid of these parentheses. So we get ay equals 5x minus 20, right? Distribute that 5. And the very last thing you need to do is just move the x over. So minus 5x. So I'm going to write this up here. So we get negative, the x goes first, right? Negative 5x plus 8y equals negative 20. So negative 5x plus 8y equals negative 20. Now I'm going to tell you, there's something that just bothers me about this notation to no end, and it's that some authors feel that first number there, that coefficient, should be positive. Some don't care. Now, if you look at this example, if you're following along in the book, if you go to page 207, you can see that Dr. Martin Gay even made a note about this. It's right above the little green words that say work practice 2. But right above it, it says, look, if we multiply both sides of this by negative 1, we have an equivalent equation in standard form. Yeah, but look, this is okay. Or look, if you multiply it's an equality, right? So I can multiply both sides by negative 1. And we'll get an equivalent equation, 5x minus 8y, right? You got to distribute, equals positive 20. Both of these are the same, but sometimes authors just like that first term to be positive. I don't know why. I don't write the book. If I wrote the book, I wouldn't even use this standard form, okay? But I know that's something that Dr. Martin Kay talks about in the book. And it's not just her. It's not just this book. This is a common thing that happens throughout algebra books. Okay. Hey, this is long. This takes a while. We're going to do another example of this. Okay. This isn't. Don't think I'm just going to leave you hanging here. Okay. We're going to do another example of this. And the goal here, though, is to get comfortable with step 1, because out of step 1, we might go to y equals mx plus b. We'll do that here in a minute. So it depends on what the question's asking here. Okay. Is it asking us to go into standard form for this one? Or is it asking us to go into slope-intercept? We'll do that here in a minute. Let's do one more of these, okay? One more of these, and then I'll ask you if you have any questions so we can kind of see it, let this soak in a little bit. I'm going to steal one from the book, actually. If you go to the homework on page 211, let's steal one of the even ones because I'm going to give you odd. Let's say number 14 here. So number 14, okay? This is on page 211, number 14, out of 3.4. Number 14 says, look, write an equation of the line passing through the given points, and then write the equation in standard form. So it goes through negative 9, negative 2, and negative 3, 10. And they want us to put this in standard form, right? AX plus BY equals C. Okay, AX plus BY equals C. Okay, again, I'm going to follow the same exact steps I did before. First, I'm going to put it in point slope form. I know it says put in this form. Well, we can't go from 2 points to this form. Okay, so the first thing I'm going to do, step 1, put in point slope form. Okay, remember that's the y minus y1 equals m times x minus x1. Okay, it's that form. So to do that, I've got to find the slope first. So m, I'm hoping this slope's a little better than a fraction. So we get 10 minus a negative 2 over negative 3 minus a negative 9. So really we wind up with 10 plus 2, that's just 12, over negative 3 plus 9. Well, that's just 6. Oh, good. We wind up with a nice whole number slope. We don't have to deal with fractions on this one. That's really nice. Okay. Now remember, once we got the slope, now we've got to put it in this form. And it doesn't matter which coordinate you choose. I don't have a 0 this time, so I don't care which one I'm going to choose. I'm just going to choose the negatives because remember, in this form, they turn positive. Like, like it's going to be y minus a negative 2. So it turns that y positive there. So I'm going to choose the 2 negatives, actually. I'm going to say y plus 2, right? Because it's y minus a negative 2 equals, now there's our slope, 2, and then x minus a negative 9. Be careful that you stick to the same coordinates. Don't use like the y from this coordinate and then the x from that coordinate. That's a common mistake. Don't do that, okay? If whatever x or y you choose, it's got to be from the same coordinate when you put it into point slope form, okay? So we got it in point slope form. That was step 1. Step 2, we're going to manipulate into ax plus by equals c, which this one will be easier. We don't have fractions, right? But again, you've got parentheses. Ax plus by does not have parentheses. So I'm going to distribute the 2 first. You get y plus 2 equals 2x plus 18. And then, okay, I've got constants on both sides. So I'm going to subtract the 2. Because remember, I've got to get the constant over here. So I've got to move that 2 over. So I get y equals 2x plus 16. Hey, you know what? If it asks for slope-intercept form, I'd be done here. Isn't that kind of neat? But it didn't. It didn't ask for slope-intercept form. Remember, this is y equals mx plus b. That's what we talked about yesterday. But it actually asked for standard form. Yeah, standard form. So I'm going to move the 2x over. So we wind up with negative 2x plus y equals 16. Okay, negative 2x plus y equals 16. Now I'm going to show you. Look, my book has all the answers, which is kind of cool. But look, I'm going to show you on 12. It says 2x plus y equals. Wait, what number did we do? Oh, did we do that? Something wrong? Oh, this is number 14. If you look at number 14, my answer here, I know it's kind of hard to see, is actually 2x minus y equals negative 16. So again, Dr. Martin Gay kind of follows this rule where you've got to have this first number positive. That a value's got to be positive. So even though you would be technically correct here, you've got to multiply both sides by -1 because she thinks that's what's important. And I just want you to know where that's coming from. 2x minus y equals negative 16. And I know what you're thinking, well, Mr. Shirley, do you care? Well, I'll tell you, the test generator that I use to make your tests, it's built by Pearson, who wrote this book. I mean, by Martin Gay, who wrote this book. So it's not that I care or don't care. It's that I'm trying to be consistent with my verbiage and what the book says. So therefore, if this question comes up on a test, it'll probably be written like this. If let's say it was a multiple choice answer, it would be written like that. Okay, so just be careful. So yes, in a way, yes, I do care because I'm going to be consistent with the book. Okay, so now that you've seen 2 examples of these, do you guys have any questions? I'm going to pause right here before we go to the next type of example. You guys have any questions? Comments or concerns? Okay. So now let's do the same, actually the same first step, but instead of going to the standard form, we're actually going to go to slope-intercept form now. Okay, we're going to go to slope-intercept form. And this is actually kind of the first example. I kind of did these out of order, which is fine. But let's say I'm going to do example 1 now. I did example 2 first. I'm going to do example 1 back on page 206. So let's say the question says write an equation of the line, and we know the slope is -3, and it goes through, your book says contains, it's the same thing, 1, -5. Now, so we've got this line, we know the slope, we know the point, there's your indicator to use point slope form. But it wants us to write the equation in in slope-intercept form. Write the equation in y equals mx plus b. Okay, write the equation in y equals. So what's different about this one is that it doesn't want us to go into ax plus by equals c to the standard form. It wants us to go into slope-intercept form. Okay. So even though it wants us to go into slope-intercept form, my step 1 is going to be the exact same. And I know it's not telling you to put it in point slope form. Remember the first thing we talked about today. But the point slope form is what gets us to y equals mx plus b or to slope-intercept form. Or to standard form. Okay. So my step 1 is going to be the exact same. Step 1. Put in point slope form. Okay, put in point slope form. That has not changed. So let's do this. Now, what's nice about this one, it gives us the slope and it gives us the point. We don't have to do any extra work, right? On the last two, we had to find the slope and then do that. So on this one, we don't have to. All we have to do is put in point slope form. So point slope form, remember, was y minus y1. Now, y1 is -5, so it's going to be y minus a -5. So y plus 5 equals m, -3, times x minus 1. So I could automatically, boom, in one step, just put this in point slope form because it gave us a point and a slope. That's nice. Okay. Step 2, manipulate into y equals mx plus b. Okay. Manipulate this thing into y equals mx plus b. Now, what's different, remember, in y equals mx plus b, our goal is to get the y by itself. That y right there, I want by itself. Okay. So instead of getting the x's and the y's on one side and the constant on the other, I want the y by itself. So to do that, again, just like before, there's no parentheses. So I'm going to distribute the parentheses first. Oh, there we go. -3x plus 3. Okay. And then on this next step, remember, if it was standard form, I would move the 3x over and move this 5 over, right? But it's slope-intercept form. I just want this y by itself. So I'm going to subtract 5. And I get y equals -3x minus 2. Boom. Okay. Kind of cool. I'm going to box that in. Okay. Questions, comments, concerns? Okay, I'm going to give you an example of this one, and I want you to try it yourself. I know I didn't do that on the last one, and if we've got time at the end, I'll definitely do that with the last one, kind of a mixed review. But I'm going to give you an example, and I want you to try it. I'm going to steal it from the book, actually. This is let's do number 4 on page 211. So number 4 says, write an equation of the line with a given slope and containing the given point. Write the equation in slope-intercept form. So the slope is -4. Writes it like this. It goes through to -4. And I want you to write in y equals mx plus b form. And I'm going to give you a few minutes to do this just to see if we're on the right track, okay? And if you don't know how to do it, that's fine. Just try it, okay? Just try. Okay, it's okay if you're still working. I'm just gonna kind of follow up behind you and just see if we're going in the right direction. So let's see here. Well, first, remember step 1. I'm gonna put it in point and slope form. No, I'm sorry. Yeah, no, that's right. That's right. Step point and slope form. Sometimes my brain gets the names mixed up. But step 1, we're gonna put this in point and slope form. Y plus 4 equals -4 times x minus 2, right? Remember that was step 1. And then step 2, all we're going to do is solve for y, right? Step 2, we're going to manipulate this thing into y equals mx plus b. Well, I've got to distribute the -4, so I get y plus 4 equals -4x plus 8, right? And then I've got to subtract the 4, and I get y equals -4x plus 4. Yep, that's it. Okay. Questions? Now that you kind of worked one on your own, something didn't make sense. You guys getting it? I hope you're getting it. I mean, not that it gets any easier or harder. It just changes. It kind of comes back to this a lot of times, though. Okay. But it's definitely different. Okay. Let's do a few. They introduce a few different ones, and we'll come back to this example here in a minute too. So let's say we've got. Then your book goes over vertical and horizontal lines. And guys, the nice part about vertical and horizontal lines is that there's no real math involved. We just have to really think about it. So let's do a quick review of vertical and horizontal lines, okay? I'm going to put vertical here. And I'm going to put horizontal here. We're going to write down all the things we know or all the things we remember, or maybe we need to know, I should say, about vertical and horizontal lines. First off, vertical lines are always x equals a number, okay? Vertical lines are always x equals a number. Now, that means horizontal lines are always y equals a number, okay? Always y equals a number. Vertical lines, the slope of vertical lines, remember, was undefined. And the slope of horizontal lines, though, was 0, okay? So vertical lines, x equals a number, and the slope is undefined. Horizontal lines, y equals a number, but m equals 0, okay? And then I'm going to steal 2 different examples out of the book from this little spot. This is number 20. Number 20 says, write an equation of each line. And it says the slope, for this line, the slope is 0. And it goes through -2, -4, okay? The slope is 0, and it goes through -2, -4. Now, it doesn't tell us what equation to use. It just says write an equation, okay? Now, the indicator that this is different, though, is that our slope is 0. So look, slope equals 0. Oh, hey, That's a horizontal line. Okay. Slope equals 0. We got a horizontal line. Now it goes through -2, -4. Now remember, horizontal lines have an equation of y equals a number, right? Horizontal lines have an equation of y equals a number. So look, this is really easy. This is all this is going to be. Our y value in the coordinate is -4. The number we're looking after is always the y value. Remember, all the y values have to be the same if we have an equation where y equals a number. That means all the y values are the same in each coordinate. We went over that a few days ago. So y equals -4. We're done. That's it. Okay, we're done. A lot easier than the last few examples we've done. So when the slope is 0 or undefined, or it tells us it's vertical or horizontal, there's no real math involved. We have to use this logic really to get it. Slope equals 0. Hey, that's a horizontal line. It goes through -2, -4. Well, horizontal lines are y equals a number. My y value is -4. Boom, y equals -4. Okay, so let's do 22. I'll do the next even one. This one tells us, hey, it's a vertical line. And it goes through 4, 7. We've got a vertical line. It goes through 4, 7. Let's choose another color. Purple. Okay, vertical line through. Okay, well, first off, it just tells it's a vertical. So boom, I know I'm over here. That means I'm going to have x equals a number as my equation, right? Now I got to go back to the coordinate. The x value is 4. Okay, and remember, just like before, vertical lines, all the x values are going to be the same with vertical lines. If you look at every single coordinate in a vertical line, the x value is going to be the same. So therefore, my equation is going to be x equals 4. That's it. Okay, x equals 4, and we're done. Those are the easiest in this for this section anyway. Those are the easiest in the sense of math, right? There's not a lot of math involved, not a lot of algebra, but sometimes they get to be the hardest when it comes to the like critical thinking. Like in these, once you know the steps, you just do them. You kind of, okay, yeah, step 1, I know this, step 2, I know that, I've got the answer. Where these, you really have to think a little bit. Okay, these are thinkers. Okay, questions, comments, concerns? Pause right here for a minute. Okay. Just if you think of something, butt in here. No big deal. You won't be really butting in. Okay, so let's look at the next type of question, which is the parallel perpendicular question. Now remember, so again, a quick review from yesterday. If parallel lines, which we can write, the shorthand notation looks like that. They've got the same slope, right? Same slope. But then perpendicular, which we got that upside down T, that's the shorthand notation. Remember, this is opposite, which means change the sign. Reciprocal, which means flip. Slope, okay, opposite reciprocal slope. So change the sign and flip it. So let's look at an example where this one comes up. This is like number 28. Man, this is going to be a tough one, I think. Maybe not. Number 28, which is on page 212, says, write an equation of the line. Write the equation in the form x equals a, y equals b, or y equals mx plus b. So we're going to do y equals mx plus b. Write in y equals mx plus b. Which one, 28? Now we know that our line goes through -4, 8, and it's perpendicular to 2x minus 3y equals 1. So we want to write this in y equals mx plus b. We know it goes through this coordinate, and it's perpendicular to this line. Whew, there's a lot going on here, okay? A lot going on. But I'll tell you, the first step's going to be the same. We want to find the point slope form of this line. Now we know the point that it goes through, -4.8, right? But we need to find the slope. And it gives us a hint to find the slope, right? It says our line is perpendicular to this line. So if our line's perpendicular to this line, that means our slope is going to be the opposite reciprocal of this line, okay? So I've got to find the slope of this line. And now remember, to find the slope of this line, I just solve for y, okay? I just solve for y. So let's do that. I'm going to solve for y here. It's going to give me the slope I need by doing that. So I've got 2x minus 3y equals 1. So I'm going to subtract 2x. Negative 3y equals negative 2x plus 1. And then I'm going to divide everything by -3. Wind up now, look, two negatives here make a positive. So that winds up being 2/3 x minus, because it's 1 divided by -3, minus 1/3. Okay, so I moved the 2x over, and then I divided everything by -3. And that put it in y equals mx plus b. So this equation I know we're perpendicular to, I've got that in a y equals mx plus b now. And the reason I needed to do that is because we know that we're perpendicular to this slope, right? So my slope that I need, since we're perpendicular to this one, remember, it's opposite reciprocal. We're going to flip it and change the sign. So -3/2, right? Flip this, 3/2, change the sign to negative. And I know we go through -4.8. It gave us that in the question, okay? So now I can put this in point slope form. I know the point and I know the slope. So I'm going to say y minus 8 equals -3/2 times x plus 4, right? Oh, man. This is a lot. Now, guys, I'm telling you, this is one of the kind of towards the end of the homework. So if you're like, oh my God, I'll never get this. Well, it builds up to this. Okay. When you get working on the homework, it builds up to this type of question. But I wanted to show you an example. That way, when you get to it and you get stuck, and if you want to come back and watch this video to see how I did it, you're more than welcome to. Okay. Okay. So we've got it in point slope form. It took us a while. We had to find y equals mx plus b from the equation that we know we're perpendicular to. We had to flip the slope and make it negative, change the sign. And we know the point, so then we put it into point slope form. So now, step 2, remember we're going to manipulate to put in y equals mx plus b. Now, again, look, I've got this fraction here, and I want to get rid of the fraction. So just like before, I'll use even the same color. Now, you got to be careful when you do this. Super careful. The denominator's 2 here. So I'm going to multiply this by 2, but I've got to multiply this whole thing by 2 over here. Okay. Remember that trick we did? I think it was in like the very first example. I got the denominator to go away to make this not a fraction anymore. But now I'm going to just work down here. That leaves us with 2 times y minus 8 equals -3 times x plus 4. Oh, I shouldn't have done that. That's fine. Okay. Now our goal, though, we're going to get into y equals mx plus b. Our goal is to get this y by itself. So I'm going to distribute the -3, and I get 2y minus 16 equals -3x minus 12. Okay. Now make sure, look, guys, I know I kind of glossed over that, but if you multiply 2 on both sides, you have to multiply everything on both sides by 2. And that's what we did. We multiplied the y and the -8 by 2. Okay. And over here, it doesn't matter because that 2 cancels with that denominator. So it's nice. It gets rid of the fractions. Okay. It gets rid of the fractions. Now, the goal now, though, is to get y by itself. Okay. The goal is to get y by itself. I really started step 2 up here. Okay. So now I'm going to add the 16 over. I get 2y equals -3x. Is that plus 4? Seems right. Yep. And now I've got to divide everything by 2. I get y equals negative 3 has x plus 2. Holy cow. That was a lot of work. And it was. It is. I mean, this is a lot of work. This is a lot of work. Okay. I know you guys, some of you guys are behind that screen saying very impolite words right now, and that's fine. This is a challenge question. Okay. This shouldn't be easy. If this is easy, that's a good thing. But if it's not, that's normal. This should challenge you. We need that. Okay. Okay. Let me think. Any questions before? Yeah, I want to hit a few more examples before we call this a lecture. Okay. Oh yeah. So I'm going to choose one from the same section, and you're going to see that it's, a quarter of the work that we're about to do. Okay, maybe even less than that. So I'm going to stick in this same little part. But so that was number 28. But let's look at 30. I mean, just 2 questions later. This is number 30. Same thing. It says find the equation of a line. Now it could be x equals a, y equals b. That's fine. But we know it goes through negative 2, 6 and perpendicular to y equals 7. Okay? Through negative 2, 6 and perpendicular to y equals 7. Now look, I'm not going to have the same step 1 and step 2 here because I'm not dealing with the same type of line. This line, and if you need to go back a few pages, bring this up here. How about that for reference? This line is horizontal. There's not an x value, right? It's just y equals 7. But now we're looking for a perpendicular line to this. So if this is a horizontal line, we're looking for a perpendicular to horizontal. Well, that's vertical, right? I mean, if you got horizontal running this way and vertical running this way, right? That means the perpendicular line has got to be a vertical line. So what we're actually looking for is, I'm going to kind of rewrite this because it's perpendicular to a horizontal line. We need a vertical line through negative 2, 6. Okay, if we need a vertical line, we'll use the same purple marker. Why not? Oh, I can find it. If we've got a vertical line, that's just x equals a number, and our x value is negative 2. We're done. That's it. This is a vertical line because it's vertical to y equals 7, right? I'm sorry, it's perpendicular to y equals 7, so it's vertical, and it goes through negative 2, 6. That's a lot less work, right? And if you have questions that are asking for vertical and horizontal lines, there's just a lot less work involved. Now you're gonna have a lot more thinking maybe, but it's a lot less work. Okay. Any questions? Trying to find some that I want to do here. They're maybe a little different. Okay, yeah. Let's look at this one. This one might be a little tricky. This is actually probably one of the last questions I'll ask in the homework. Okay. This is number 58. 58. The question states we go through negative 4, negative 2, and negative 6, 5, but they want to use slope-intercept form. They want us to put this thing in slope-intercept form. So remember, that's y equals mx plus b. Okay. y equals mx plus b. They want us to put this in slope-intercept form, y equals mx plus b. Okay, great. So now we're going to do the same thing we did earlier. So and this is not vertical or horizontal lines. Maybe it is. Maybe with this slope we find out that it's vertical or horizontal. But the first thing we need to do is really put it into point slope form. That's the theme here, right? Unless it's vertical or horizontal, the first step has always been the same. Put in point slope form. Well, we've got two coordinates, so we need to find the slope first, right? Remember, this is a lot like the very first example we did of these anyway, but instead of going into ax plus by equals c, we're going to go into slope-intercept form. So first, let's find the slope. So m equals 5 plus 2, right? 5 minus a negative 2, and negative 6 minus a negative 4. So negative 6 plus 4. So we wind up with 7 over negative 2. 7 over negative 2. Now, I'm going to write that, of course, as negative 7 halves. Look, with a negative value, as long as it's a single negative value, you can write it in 3 different places on a fraction. You can write it in the denominator. That's fine. You could write it out front, which is what I'm about to do math, or you can write it in the top. Okay, there's nothing wrong in that. They're all equal to each other. You know, whenever I'm graphing, I like to put the negative on top. Remember, I talked about that yesterday because of the rise and the run. But if I'm just doing algebra, I'll stick it out front. Okay, so we're gonna use this one as our slope. Now, again, I'm just gonna use this first coordinate to put it in to point slope form, right? It doesn't matter which coordinate we use. We'll wind up with the same answer. But I'm gonna choose this one. So y minus 2, or y minus a negative 2, so y plus 2, equals negative 7 halves times x plus 4. Okay? Negative 7 halves times x plus 4. And again, look, we're going to do our little trick we learned earlier, that if we've got fractions and it's all being multiplied, let's just multiply both sides by 2. Okay? Multiply both sides by 2. Oh, wait, let me put step 2 in here. Step 2, of course, is now we need to put in y equals mx plus b. Manipulate into y equals mx plus b. So we've got to solve for y here, okay? We got to solve for y. And again, to do that, I'm going to get rid of the 2, in the denominator. So distribute this 2 to both terms over here. We get 2y plus 4. On the right, though, it's nice. It got rid of the 2 in the denominator, so you have negative 7 times x plus 4, right? So get rid of those parentheses. Negative 7x minus 28, right? And then, now the goal for this one is to get y by itself. Remember, if it was standard form, we would move the x over and the number over, right? But for this one, we want to get this y by itself. So the first thing I'm going to do is subtract the 4 over. Remember, get the constants away and then divide the coefficients. So 2y equals negative 7x minus 32, right? Minus 32. Yep. And then I'm going to divide 2 by everything. So I get y equals negative 7 halves x, right? Negative 7 halves, minus 16. But I'm done. That's not as bad as that one we did before. You know, the perpendicular stuff does make it a little more difficult. The perpendicular and parallel, it adds a little more steps because you've got to find, if it's perpendicular, the slope, right? You've got to find the slope if it's perpendicular and parallel. Where up here, all we had to do was use the 2 coordinates to find the slope. Okay. Questions, comments, concerns? Okay, so for homework, and stick around here a minute because I'm going to go over the test a little bit. But for homework, you need to do, and I'll tell you, this is the toughest section on the test, okay? You need to do 1 through, I'll give you the page here in a second, 1 through 57 odd. It starts on page 211, and this is from section 3.4, okay? From section 3.4. Okay, 1 through 57 odd. I'm about to switch back to my face, so you can write this down. 1 through 57 odd, page 211, section 3.4. Okay, I'm going to switch back to me for a second. Let me see if I've got this. There I am. Oh, God, I got to trim this beard. It's looking rough. Okay, so first off, if I might use this video later on some other semester. So this is from the spring 2021 video. So if the directions I'm about to go over are for that semester. So if you're watching this in the future, just realize you need to go off the instructions that I gave your class for that semester. So guys, I'm going to open up the test. I'm going to make the test here in a few hours. I've got another class I have to teach, and then I can make the test after that. Remember, it's worth 50 points. Once you start the test, you have to finish it. So once you click begin, you have to finish it. I'm going to give you an hour and 15 minutes, just like a regular test time. And it doesn't matter when you take it. It just has to be done by Sunday at midnight. Okay, so I'm going to open it up. You'll receive an email. You should receive an email in your student account or your announcement email, and then the due date will be Sunday by midnight. I haven't made it yet, of course, so I can't tell you like how many questions or anything of that nature, but I'll tell you it's not a big test. I made these all small bites for this class because it is the 7-week class. So it shouldn't take you long to get done. I'm trying to think of other questions students have had. I mean, you can use your notes. That's the best part of this class, really. But realize you're on a timer. You can't go into this thinking you're going to learn it as you're taking the test, because it's timed. So you will run out of time if you have no idea what's going on. Okay. So you need to get the homework done so that way you can utilize your notes when you're taking the test, right? It's not just that you're showing up blind. Okay. And I promise if you try to do this test without doing the homework, it's going to be a rough ending. Okay. A rough ending to that flight. Okay. Did you guys, okay, I'm going to pause it here. Actually, do you guys have any questions? That way, if a student watches this and sees it, do you guys have any questions about the test or this section? Either one's fine. I'll give you a minute. You can put it in the chat or you can butt in. That's fine. Okay. Well, if you think of a question, email me.